Okay, so we'll have a look at another electromagnetics question. This time we're told a 1 meter length of wire carrying 9 amps is in a perpendicular magnetic field of 0.01 teslas. Find the force on the wire due to the field. Okay, so we'll draw a diagram of this. We've got a 1 meter length of wire. So let's draw our meter long length of wire like this. This is 1 meter. We are told that it is perpendicular to a magnetic field. It has a current running through it of 9 amps. Let's make the magnetic field go into the page. Doesn't really matter which way we orient, it could be into or out of. Both of these directions are at right angles. Now we want to work out the force. Well, in our diagram, the force will either be up or down, depending on which way the current is going. And it doesn't actually tell us which way the current is going, so we might assume that the current is going to the right. So it's 9 amps to the right. Now we need a particular calculation for this. We know that the force is equal to the length of the wire times the current in the wire times the strength of the magnetic field. This is in the case where the wire and the field are perpendicular, so they are at a 90-degree angle. So the length of the wire is 1 meter, the current in the wire is 9 amps, and the strength of the magnetic field is 0.01. So this ends up being 9 times 10 to the minus 2, and this is newtons. Now if the current points to the right, so if the current points to the right, and the field goes into the page, which is the setup that we've selected here, we use our right hand rule. We point our index finger in the direction of the current. We point our middle finger in the direction of the field. The direction of our thumb tells us the direction of the force. This is going to be directly up. So in this case, the force due to the magnetic field will be directly up, and it will have a magnitude of 9 times 10 to the minus 2 newtons. It's worth doing these questions separately. It's worth doing the magnitude using the formula and then looking at the diagram and using your understanding of the system to work out the direction. You can get the direction from the formulas if you very carefully lay out which values are positive and which values are negative. In these questions, that tends to be more difficult. So it's just better to use the formula for the magnitude and then evaluate that to get the number, and then use intuition about the nature of the field to work out the direction of the resultant forces.